We're going to spend a day just working on our fractions. Today we're going to start with reducing rational expressions. And so this is actually something you've been doing for quite a while. Like if you have 4 over 6, you know that's going to reduce to 2/3. But what's really going on is you can factor these, and if you break it up into all its factors, you're canceling out things that are in common. So that's why we have 2/3. Okay, so if we start to include variables, it is the same idea. This really, we could write out now that's times right there. We have 2 5s that will cancel. We have x's that will cancel. Really, that's xy over 2. Okay, so if we encounter something with polynomials and we get a rational function here, well, in this case, we factor, just like we were factoring or breaking things apart above. And on the bottom, we have x plus 3, x plus 3. Now, when we break it up like this, we realize we have that and that. And if you're graphing rational expressions, you know that when this happens, this is actually a whole. But for now, we're just reducing, so we can write our answer as x minus 3, x plus 3. Now, the number one mistake people will make is they will try to reduce these x's here. But you have to understand that this is not factored right now. This is one factor in itself, and this is one chunk in itself too. So this is our final answer. Now, proof of this is, if I do x minus 3 over x plus 3, and I reduce this, I will get -1. But if you go back to this, and we say put a 2 in for the x, 2 minus 3, all over 2 plus 5, now if this reducing actually works, we should be getting -1, but instead we get -1 over 7. So we cannot just say that this is -1, and we can't reduce this. This is a no-no. Alright, so we got to look at a few more examples here. So there's a lot going on with this one. There are many factors we have to get out of this. But first of all, realize when you multiply, you could actually combine these to be the same fraction. Just like if you have 2/3 times x over 3. Normally you just multiply the tops and the bottoms. So before we multiply and combine everything, I'm going to factor the top here. This is x minus 3. Oops, wrong factors here. What goes into 5 and would add up to -6? That's a -1 and -5. Alright, downstairs, I can't factor that same way, so I'm going to pull out a GCF. It's just x. Times, the one on top is, we've seen this already, for difference of squares. Down here, this would be x minus 3 and x minus 5. Now, you may have learned, like, if you have 4/10 times 28, you may have learned that you could reduce before you even multiply across. Like this 4 and this 8, we could divide a 4 out of each. And then we could divide a 10 out of this, and a 10 out of this. So really, we're going to have 2 over 2, which is 1. Okay, same as here. So there's an x plus 3 here and an x plus 3 here. We get to cancel x minus 5 and x minus 5. And actually, x minus 3 and x minus 3 cancel. When all is said and done, all I have left over is this and that. So my answer here is x minus 1 all over x. Now, ladies and gentlemen, the way that this one works, you could actually butterfly if you wanted to. And that would get you 1 minus 1 over x. But really, that is not necessary. So as our final answer, you could just leave it like this. And actually, I find the less you try to tinker with that final answer, probably the better you are off. Okay, now we have to do one last example here with simplifying. So I've written out a division problem here. And just like when we had fractions before, if you are going to be dividing fractions, you keep the original one, you change it to multiplication, and you multiply by the reciprocal. So in this case, this would turn out to be 1/3. Same thing here. We're going to keep this original fraction, and at the same time, I am going to factor it, because I'm going to have to do that anyways. But instead of multiplying or dividing, I'm going to be multiplying instead now. Now guys, this one right here is going to be x times x minus 2, but because it's on the top, I'm going to write it down at the bottom. I'm making it the reciprocal. The same goes for the bottom here. 5x comes out of the bottom, and then we will have x plus 8 left over. So I did two things here. I factored the top and the bottom, and then I wrote it as a reciprocal. Now I can look and see, are there any things that reduce? I see x minus 2's. I see an x here and an x here. And actually, there was an x right there that I could have reduced that with, but it's okay. We'll get the same answer. And also, 5 and 20 I could divide by 5. So that'd be 1, and that would be 4. Now there's nothing left that I can reduce. So I am going to write everything that's left over on top, and whatever's left over on bottom. And traditionally, we want to expand it out again. So that's x squared plus 10x all over 4x. Now guys, realize this problem could have been set up differently. This original problem, division problem, could have been a fraction over a fraction, which then would just be the same, but just be aware. So you'll see that. That's a fraction over a fraction. Just remember, you can always rewrite it like this. Keep in mind that that's a division.